So we're finished with section 10.1. Now, before I do that, so real quick, this is on page 603,
Quick review.
number 64. You have this. And the directions also say just assume that all variables represent positive numbers. So you don't have to worry about absolute value in that case. All right, now that was an easy section, but if you didn't look at absolute value. The rest of the problems were fairly easy. What's this answer right here? What's the cube root of a negative 8, 8 to the 21st, b to the 6?
Negative 2 to the...
Negative 2, negative
2a.
7.
A to the 7,
B to the 2.
b to the 2nd. Only a few of you were able to do this. Okay? So that tells me that I'm glad no one turned in 10.1 yet.
Yeah.
No, you got to realize we spent that whole time studying for that test, and
Well,
this probably
we had, but
put it by the wayside a little bit.
you had yesterday.
Oh.
So the cube root of a negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. And then for the variables, the exponent, remember, basically you're taking the exponent, dividing it by, and what's this right here called? The index. You divide by the index. 21 divided by 3 is 7. And then 6 divided by 3 is 2. Now, we're about to do something where, see how the index, the exponent was divisible by the index?
Mm-hmm.
That's not always going to be the case. So we're about to do stuff like that. Well, what happens if this is a 20?
Scratch your head.
So, of
Right.
course, we're going to get decimals, right?
No, you're not going to use decimals. No, you never use decimals. Okay, so that we're going to talk about that situation soon.
Calculate.
Okay. All right, so you need that idea with what we're about to do. Okay, so here's what we're about to look at. So this is going to be section 10.2. Now 10.1 was called radicals. That was 10.1. All right, radicals. And so the radicals, you have this radical notation. This is the index. This is a radicand. All right, what's underneath the radical is the radicand. 10.2 is where they start talking about the word rational exponents. Okay, rational exponents. That's 10.2. All right, now, in the previous section, 10.1, when I had the fourth root, now assume that the variables represent positive numbers, if I had the fourth root of x to the 8th power, we said the answer was what?
X to 4.
X to the second.
X to the second. X to the second. And so basically you said this was x to the 8 divided by what? 4, right? That's what you said. And so that would be x squared. So what you to notice is that the index became your denominator and the exponent was the numerator. So when we talk about rational exponents, the way it's going to look is this. It'll look something like this, where you had the a root of x to the b power. The a root of x to the b power. And I want you to write it. Now, rational means, think of the word fraction. Rational, think of fraction. So, you see, this is a fraction, right?
Mm-hmm.
All right, so I can write this as x to the what fraction?
A divided by B.
No,
B
dude.
B divided by A.
B divided by A. You keep missing this. You miss it here, you miss it here. Don't miss the next one.
Okay.
All right. So that is rational exponents. That's what it is. That's what I mean by that. Rational exponents. Your exponent is a rational number. It's a fraction. Okay? So one of the rules is the idea of the definition of a to the 1 divided by n. A to the 1 divided by n.
Is that thing giving you problems?
So if you go backwards, how, you see how this is written as rational exponent? So I can go from a rational exponent to a radical. You can go backwards. You can go from a radical to a rational exponent. You can go from a rational exponent to a radical. So I want you to rewrite this as a radical. What would that look like?
Be the
Say it again?
8n/1.
No.
No, do your little root
The-
symbol.
Okay, what's
and
the
then put the
index?
N up there.
N
and
right
put
there.
The A with the
A.
1.
to the
Right, or
first.
just
Yeah.
A. So a to the 1 over n is just the n root of what? A. That's what that is. Okay? So that's the definition of a to the 1 over n. So it's just the n root of a. So remember we talked about the index is your denominator, your exponent is your numerator. So you can go from a radical to rational exponent, you can go from a rational exponent to a radical. So you got to be able to go from left to right, right to left. Okay? So if I extend this and I write this as a to the b over, let's say, a to the n divided by m, so I have this rational exponent, how can I write this as a radical?
Put your
Okay, I want you to use the correct terminology, David. You're going to say the m root,
root
the m root of what?
A
A to the,
N power.
okay? You got to use the correct words. So the m root of a to the n. All right. Now, you see how the n is located under the radical?
Mm-hmm.
You can also write, and this is going to be important as we go through some of these problems, you can also write it as this. The m root of a all raised to the n power. That means the same thing. And make sure you understand that it does mean the same thing, because listen carefully to this. Listen carefully. So you can write the exponent under the radical, or you can write it where? Outside. This makes sense because that's part of the definition. Here, for some of you, makes, well, how's that the case? Well, the n root of a as a rational exponent is just what? A to what power? The m root of a is just a to what power? 1 over m. All that's raised to what power, though? N. So remember the power rule. When you have a power raised to power, what do those powers? Multiply. So that's a to the, and what's 1 over m times n? What fraction?
Say that again?
What's 1 over m times n?
n/m.
N over m. And isn't that what this is? Okay. So from there, you can see that in some cases, and it's going to be needed, you may want to rewrite the exponent on the outside. You're going to see where that's going to be important soon. All right. So a rational exponent, that's what this section is. The rational exponents you can always write as a radical. And you can always write a radical as rational exponents. So when I had the square root of, well, let me change it. When I had 16 to the 1/2, can you tell me right away what you think 16 to the 1/2 is?
8.
Nope. It is not 8.
Square root of 16.
Square root of 16,
4.
which is 4. So you forgot to change it to a radical. 16 to the 1/2 is the square root of what? 16. And the square root of 16 is 4. So you got to remember, when you have rational exponents, you want to write as a radical. And then simplify. Okay? So that takes us to these examples. Let's see these examples. All right, so this is going to be on page 610. And this is going to be number 4. You have 8 to the 1/3 without using a calculator. What is 8 to the 1/3?
Cube root of
The
8,
cube root of 8. Cube root of 8,
which is 2.
which is 2. There's your answer. So in the blank, on the worksheet, where I have 8 to the 1/3 equal blank, don't put the cube root of 8.
Put the 2.
You put the 2 there. That's what it equals. All right, so that's 4. 12. You have, in parentheses, 16, x to the 8 power, raised to the 1/2. How do you think you're going to do this?
4.
No, don't tell me the answer.
Oh,
Tell me
okay.
what's
square
the
root of
next
16,
step? Hold on, David. What's the next step you're going to do?
Convert it into the
Write it as a radical. Okay, so tell me what you're going to write.
Square root of 16 x to the 8.
And now that looks like the previous section. What's the square root of 16?
4.
What's the square root of x to the 8?
4. X to the 4th.
X to the 4th, right? 8 divided by 2 is 4. So you'll agree that's 4x to the 4th? Square root of 16 is 4. Square root of x to the 8. Got to remember this. Remember this right here. If you got to go further, if you have to go further, remember that's the square root of 16 times the square root of x to the 8, right?
Mm-hmm.
Square root of 16 is 4. This right here, based on what we just talked about, isn't that the same thing as 8 divided by 2?
Mm-hmm.
All right. So if you could not go from here to here, then you need to do this part. You need to do this right here. All right, so that's 12. All right, then let's look at 14. All right, 14. You have negative 64 to the 1/2.
Square root of negative 64.
All right, so he said square root of negative 64, and so what would you put in the blank?
Negative 8.
So you're telling me that a negative 8 times a negative 8 is a negative 64?
No real number, right? Because no,
So no number times itself.
It's an absolute value.
no,
No.
because it's
No number times itself is negative. A number times itself is positive or 0.
So it's no
We
real
talked
number.
about it.
Oh,
But
yeah,
that's
true.
it's still not correct what he said, though. Not one person said, no, you're wrong, David.
That's your job.
We learning just like David.
You what?
I'm learning just like David. I'm not gonna. I'm still trying to catch it. I ain't gonna lie.
I mean, we all know you throw these.
What is the only thing that's being raised to 1/2 power? The 64. We talked about this idea before. We talked about the difference between 4 squared versus negative 4 squared. I'm sorry. Negative 4 in parentheses squared versus negative 4 without parentheses squared. In the first one, what's being squared?
negative,
Negative 4. That means negative 4 times negative 4, which is what?
positive 16.
16. Here, what's being squared?
A negative 4
No, no, no.
Just a 4.
4 is the only thing being squared. So what is 4 squared?
16.
And so this becomes a negative 16.
Oh,
So then going back here, what's the only thing being raised to the 1/2 power?
that's 64.
The 64. If I wanted negative 64 to be raised to the 1/2 power, I would have to put negative 64 in parentheses. So 64 is the only thing being raised to 1/2 power. Now change your answer. What's the answer?
8.
Not 8.
Negative 8.
Negative 8.
What Seven?
No, you said 8.
The first time around?
Yeah.
I'm pretty sure I said -8, because I mean, that's logically, I would have looked at that and.
But you said -8 for the wrong reason, David. You said the square root of -64. Square root of -64 is not -8. Square root of -64 is not a real number.
I understand now, and I guess I gave the right answer for the wrong reason.
And you would have lost your points.
Yeah.
Okay? Because you gave me something that was mathematically incorrect. All right. So the square root, which is what you said, is not -8. And that's what you said. Square root of -64 is not a real number. Put that in your calculator, you're going to get a domain error. Now you're going to learn pretty soon that that's an imaginary number. So that's where you would say 8i. This is really 8i. And you're going to, that's towards the end of this chapter. You remember the I? Imaginary numbers from high school?
Yeah, I never went there.
You did. It was a long time
Oh,
ago
no,
for you.
Absolutely not. I took Algebra 1 and was thankful I got out of it. I took Geometry, and then I took Business Math and said goodbye.
I know. Back then it was what, called senior math? Senior math? 1960.
You had the choice of taking Algebra 2 or
1964.
Business Math. Business Math was like balancing a checkbook.
All right. So here, the way you write this, you say negative square root of 64. That's what this looks like, not this. All right. So what's the square root of 64?
Square root of 64 is 8.
8. So this becomes a -8. So that's the answer. All right. So that's 14. Now, the next one says this. You have number 10. Number 10 is 2m to the 1/3. Now the directions, all of this is part of the same directions. The direction says use radical notation and then simplify if possible. All right, so the first thing you do is write this as a radical. So what's this as a radical?
Pull it down. Pull the page down a little.
What's that as a radical?
Is that 2M?
That's 2m raised to 1/3. The direction says write as a radical. So all of this was the same directions.
Yeah, so the cube
Root of 2m. Okay. So we wrote as a radical. Then it says simplify if possible. See, we wrote this as radical, right?
Mm-hmm.
And then simplify if possible. Could I have simplified this right here?
Mm-hmm.
Yes. What was the answer?
8,
-8. So I get the cube root of 2m. Then it says simplify if possible. Can I simplify this? No. So there's your answer. Okay? You cannot tell me the cube root of 2 is something else. Now, it's a decimal, but you're not using your calculator with this. So the cube root of 2m, you cannot simplify. Okay? All right, and then let's look at 18. All right, now watch carefully. This, you're doing the same thing, the same rule. So this time you have 4 to the 5/2 power. 4 to the 5/2 power.
Square root of 4 to the 5th.
Okay, so the square root of 4 to the 5th. Now, remember, you don't have access to calculator. You're going to do this without a calculator. So the same directions, write this as a radical, and then simplify if possible. So he said this. He said, all right, well, my denominator is 2, which is the index, right?
Mm-hmm.
So the square root of 4 to the 5th, and that's what he says. Now, remember, he's not using a calculator. You can't use a calculator with this. Now you got to go further with it. Now you got to figure out what?
What 4 to the 5th
What
is?
4 to the 5th is. So then you got to say, all right, 4 times 4 is 16. 16 times 4 is 64. 64 times 4, and now I've got to start writing these things out.
Yeah.
Any idea?
I'm sure there's a shortcut that you're going to tell us.
Subtract the what?
Can you subtract the index from the?
Oh, no.
Not that?
No, you got to use your rules.
Okay.
I'm sure there's a shortcut, but we don't remember what it is. If there is.
God, it was just 5 minutes ago, guys. Lord have mercy. You remember this? Put the exponent on the outside.
Oh.
So the square root of 4.
So this is, now watch how much simpler this becomes. Remember a while ago when we did this, I said you're going to need this idea in some of the situations? So, dude, you're gonna make me start taking nerve pills. So the square root of 4, all raised to the 5th power, and that makes it easy. What's the square root of 4?
2.
2. And now all you gotta do is figure out what 2 to the 5th is. That's a lot easier to deal with than 4 to the 5th.
32.
32 is the answer. There's your answer. So 4 to the 5 halves, you rise a radical, and then sometimes it's a lot easier to pull that exponent out on the outside. So it was much easier to figure out what 2 to the 5th is than to figure out what 4 to the 5th is, and then take the square root of that. Okay? So that was 18. 28. You have 49 over 25 raised to the 3/2 power. 49 over 25 raised to the 3/2 power.
Square root of 43
Okay,
over
first of all, you're going to change the radicals as a square root
that fraction.
of 49 25ths.
The third power.
Where do you want to put the third?
I guess you can put it outside the parentheses.
Yeah, I would put outside the parentheses. I wouldn't put it inside because then you have to figure out what 49 times 49 times 49 is, right?
Yeah, that could be a pain in the butt.
All right, so do this. And now it becomes easy. What's the square root of 49?
7.
What's the square root of 25?
5.
And now you're raising that to what power? The third. So it's a lot easier to deal with. 7 times 7 is
49.
49, and then 49 times 7 is,
Yeah, you gotta work it out.
I mean, that you have to do, but it's a lot easier than saying 49 times 49 times 49. So 9 times 7 is what, 63? So 28 plus 6 is 34. So that's 343. 5 cubed, you should know. 5 times 5 times 5 is what?
5 times 5 is 25. 5 times 25 is 125.
125. So there's your answer. So 343 divided by 125. So notice how easy it is to pull that exponent on the outside. All right, so then 24. It's not that difficult as long as you know that rule, how to change a rational exponent to a radical. That's all it is. 24, you have 2x to the 3/5 power. All right, so the directions will say use radical notation.
What's the terminology for a fifth root?
The 5th root.
Oh, okay.
Fifth root,
I finally
sixth
got the
root.
terminology
So
right.
you use the TH sound. 6th root, 7th root, 8th root, 9th root, 10th root. So the 5th root of what?
2x, and then the third is probably outside the parentheses.
Oh, you forget so easily, man. What is the only thing being raised to the 3/5 power?
Oh,
The x. The 2's not being raised to that power. It's only the x. If 2 is raised to that power, it would have to be inside the parentheses. So now tell me what you would say.
the fifth root of 2x to the third.
Oh.
The 2 is not being raised.
2 times the 5th root.
2 times the 5th root. 2 times the 5th root of x to what power? The third. That's your answer.
Okay.
The only thing being raised to the 3/5 power is x. So if you need to cover that 2 up, so there's a 5th root of x cubed, and then the 2's on the outside.
So there would have been parentheses in the problem if you would have wanted, like I was trying to say.
Yes.
Alright.
Now, remember the directions will also say simplify if possible. I can't simplify that. So that's why I left the 3 under the radical. I left the 3 there. So mathematically, if you can't simplify, just leave the exponent under the radical. Now, if you wanted to, I wouldn't take off any points if you did this. All right, I mean, no big deal. You can write it like that too, but it looks better if you leave it like this. It looks better if you leave it like that. So this is the preferred answer. All right, now 22, negative 8 to the 4/3. Negative 8, oh, I'm sorry. Well, that's fine, that's 20. So this is 20.
Okay, so now you
Negative 8 to the 4/3.
now it's inside the parentheses.
So how would you write this as radical?
Cubed root of negative 8 to the third.
And where you want to put the third?
Yeah, that's
The fourth. Where you want to put the fourth?
Oh, the fourth.
Outside? Yeah. What's the cube root of negative 8?
Negative 2.
And I'm raising that to what power?
Fourth.
So what's the answer?
So cubed of negative 2 is positive 4.
negative times negative 2 is positive 16.
Yeah.
16. All right, and then 22. 22, you have negative 9 to the 3/2 power.
Square root of negative 9 and then the third power outside of the parentheses.
Square root of negative 9 would be the
Positive, see, positive 81 times negative 9.
No, you multiply.
What's the cube root of negative 9 to the third? Don't use a calculator. What's the square root of negative 9 to the third power?
I mean, it's 81 times negative 9, whatever that is.
Where are you getting negative 1 from?
he's multiplying 9 times 9 times 9.
Why?
He wants the square
You're,
root.
you're,
of the
okay,
negative
so
9.
if you're looking at the square root of, let's say,
Oh,
16,
okay.
what number times itself is 16?
4.
4. So if you look at negative 9, what number times itself is negative 9?
Oh,
Negative.
negative 3.
Negative 3 times negative 3 is a positive 9.
Okay.
Negative 9 times negative 9 is a positive 81.
Oh, crap.
It's the
This is one of them tricks.
the what's with this,
Lord help them.
You're supposed to go outside.
Lord help them.
oh, I already know what that was. So,
It's not a real number.
yeah, I tried saying that last time. And you proved me wrong. I don't want to hear it's not a real number now, because when I say not a real number, you're like, no, it is a real number. And then we do problems that only have letters, but this is math. So I'm done answering. I'm just going to watch. Because I call it shenanigans.
You know, the shenanigans in at a bar.
Yeah,
Where's that at?
I don't even know.
Not a real number. You can't. The square root of a negative 9 is not a real number. Soon, though, you're going to see that the square root of negative 9 is 3i.
That's what I was thinking, the 3i, but no.
We haven't got to that yet, so you can't say that.
Yeah, see, so I'd be penalized for saying something that I know that we haven't gotten to yet.
Yes, you would have. All right. Now, okay. Now, let's kind of review something from a previous course. What is
Yeah, that's on Plank Road.
2
On Plank Road.
to the negative third power? All right, y'all, you do realize that it's being recorded, right? So all this Plank Road stuff is being recorded.
You knew it was a bar, not us.
Yeah.
All right, 2 to the negative third. Do you remember what that is? Don't remember, right? Okay, so let's talk about negative exponents. This was from Math 98. So negative exponents. So if I have b to the negative 1. So the idea is to always try and make your exponents positive. You want your exponents to be positive. So b to the negative 1, b to the negative 1 is the same thing as saying 1 over b. All right. So if I have b to the negative second, then that becomes 1 over b to the second. if this is b to the negative third, then that's 1 over b to the third.
Okay, so you have
All right? So this right here, 2 to the negative third, then can be written as what?
1 over 2.
1 over 2 to the third, which is 1 over what?
1 over 8,
1 over 8.
or 1/8.
Okay, so 2 to the negative third is 1 over 2 to the third, which is 1/8. Okay. Then we also talked about this in a previous course. What if I had 3 divided by x to the negative fourth power? So now, so the idea is this with negative exponents. If the exponent's negative in the numerator, where do you bring it to make the exponent positive? In the denominator. If the exponent's negative in the denominator, where do you bring it to make the exponent positive? In the numerator. So what do you think this is right here? Everything else stays where it is. What's the only thing being raised to negative power? The x. 3 is not. 3 is being raised to what power? The first. All right, the first power. So the x is the only thing you moved. So where do I need to bring x to the negative fourth? To the numerator, which becomes x to the fourth. So what's the answer, though?
X to the 4th divided by 3.
No. The only thing you move is the one that's being raised to the negative exponent. Everything else stays where it is. Where is 3 right here? In the numerator. It stays there.
Okay. So 3x to the fourth?
3x to the fourth. That's the answer. 3x to the fourth. You don't take the reciprocal of that fraction. That's not what this is about. Okay? All right, so knowing this little part here, that was a quick review from a previous course. Usually you spend a lot more time on this in that course in Math 98. So knowing this right here, knowing this, let's look at this example. So this is number 30. Now think about what we just talked about right here. You have 64 to the negative 2/3. Now the direction says this. Write with positive exponents and then simplify if possible. So first of all, what does that look like?
The cube root.
You are not listening to me, David. Write as positive exponents first.
Oh, you got to bring the.
How do you write this so that way 2/3 is positive? 1 over. So 1 over 64 to the what? 2/3. Now change it to a radical. What's that as a radical? You got to say 1 over. 1 over.
Or the cube root.
Cube root of what?
64 squared.
64 squared, like that. Simplify if you can. Can I simplify the cube root of 64? What number times itself 3 times is 64?
4.
4. So this becomes 1 over 4 what? Squared. So what's the answer?
1/16.
1/16. That's the answer.
Holy crap, I got to do it.
And so notice that I had a negative exponent. I have to first of all write it as a positive exponent. Then I change it to radical notation. And then I simplify. Okay? So this section has negative exponents as well. So before you change to radical, you got to make sure that exponent is what kind of number? Positive. 32. You have negative 8 to the negative 4/3 power. Before you change that to a radical, you need to make sure the exponent is positive. So how do you rewrite this so that way the exponent is positive?
1 over
1 over.
the cube.
1 over. Don't change it to radical yet, David. Change it to this step
over-
here. 1 over
over-
what?
1 over -8 4/3.
All right, write it like that first. Now change it to a what?
Right.
A radical. So what's that?
The square root of
1 over,
the square root.
where are you getting square from?
Or
Cube root.
-8 and 4 outside of the parentheses.
All right. Now simplify. So you wrote it with positive exponent, then you wrote it as a radical. Now you're going to simplify. What's the cube root of -8? What's the cube root of -8?
-2.
-2.
-2 times -2 is +4 times -2 is -1.
So 1 over -2 to what power?
That's a 4.
4. Now what's -2 to the 4th?
+16.
Positive 16. So it's 1 over 16. I don't see any smoke there.
It's coming out
What?
of my eyeballs right about now.
Yeah, it's on your final. And then you're about to have a heart attack.
And don't forget about test 4.
And then don't forget about next semester.
What? You mean this ain't one of the things that gets dropped by the wayside?
I cannot. I'm gonna have to skip this until you teach it because I cannot.
You'll be fine.
No.
All right. Number 36.
Oh, wow.
You can do it. You can do it. Just go back and review. Y to the -1/6. Girls having hot flashes.
Yeah, the only one.
Yes, she is. Look at her. Girl, drink your water.
It's hot. The water's hot.
Girls having hot flashes. Cynthia, you got to help her.
Miss Cindy about to leave me too.
Oh, my Lord.
You brought you a polar pop, would you?
So that's a Y, correct?
All right, so Y to -1/6.
So 1 over.
So
1 over,
and then write the whole thing.
Y to the
Negative.
Positive.
positive
1/6.
1/6. And then how do you write it?
1 over.
6 root of y. Now, here's the situation. The direction says this. Direction says write as positive exponents. So always read the directions. Write as positive exponents. Okay, did I write as positive exponent? Yes. Then it says simplify if possible. So even if I wrote this as a radical, I could not simplify. So you can leave your answer like this. This is fine. You can leave it like this. Now, if you want to go further, you could. I'm not going to take off any
So
points.
that's 1 over y.
The 6 root of y. I mean, if you want to write that, you can. But the only reason why and remember the directions here are all the same. Write as positive exponents and then simplify if possible. So here, where are you going?
I'm good.
Well, she didn't feel good either, but look at her. Huh? All right, girl. All right. So here you wrote as negative as positive exponents, but you want to see can it simplify further. So to simplify further, you have to write it as a radical, and then you could. Here I wrote as positive exponent, and then the question is, can I simplify this further? Even if I wrote as a radical, I could not. So this you can leave it like this. Okay. All right. Same thing with 38. Think about 38. You have this in 38. You have 1 over n to the -8/9. What's the first thing I need to do? Make the exponent positive. So what is this the same as? What's the same as?
Just move it to the top, right?
What is the same as?
In
Into the 8/9.
Yeah.
Now look, if I had this, see how the numerator was a 1? What if I had 2 divided by n to the -8/9? What would
2 in.
2 n to the 8/9? Okay, so good. All right, see the difference?
Mm-hmm.
Okay, now here's the question. If I write as a radical, is that going to help me simplify at all?
No.
No, because that's a variable n, right? So you can leave your answer like that. That's your answer. That's your answer.
Alrighty then.
Okay? Any questions? What about 40? Now, don't let 40 throw you off. I mean, think about what we just did right here with this 2. Okay, you have 2 divided by 3, y to the negative 5/7.
6y.
No. You bring it 3y negative.
What's the
Right.
only
You gotta
thing
move
being raised? Y is the only thing moving. Everything else stays where it is.
So 2y.
2.57 divided by 3.
Yeah, you knew he was going to get us.
Okay? You got to remember everything we've talked about. So you need to go back and look at those videos. So the only thing that's being raised to negative power is the only thing you move. Everything else stays where it is. Now, if I can I simplify this any further? Is changing this to a radical going to make me simplify this further?
Basically, anytime there's a variable, you can't.
No. Right. So that's the idea. If it was a number, then I would try. All right. Okay. Now, what about this? Okay, it's almost 8:15. All right. So let me see what I can give you. All right, it's not that bad. So what I need for you to do,
You do realize.
poor girl, what I need for you to do is to go back over these notes in the video, because we're almost done with this section. It's really not that difficult. You just got to learn these rules. Now, the only bad thing is that it's been a while since you had stuff about negative exponents from last semester. So you forgot. If you don't use it, you forget. It's kind of like all these little shenanigans. You forget things.